Okay, kids, so question 14, got a question and a discussion about this. And this is all about standing waves. That we had some videos about standing waves that were part of this week's lessons. And those kids who were in class, we saw some standing waves. Now, when we have standing waves, you have to remember that there's a material. In this case, it's 6 meters worth of material. It's a string or spring, whatever it is, and it's 6 meters. And in this 6 meters, you're going to have some waves coming in this way and other waves coming in the other direction in the same material, and they're going to interfere with each other. This is what we did in class. When they interfere with each other, they produce what we call a standing waves. Now, the key to a standing wave is that the distance between successive nodes, so one node to the next node, to the next node, to the next node, and in between nodes we have antinodes or loops. So remember, the antinodes or loops is where constructive interference is occurring, right? That's occurring what I'm drawing right now, constructive interference. And in the nodes, here, 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 and here is where destructive interference occurs. But one of the things that we should have learned is that the distance from node to node is always half of a wavelength. Node to node, always half of a wavelength. Between successive nodes, we always have half of a wavelength. That's really the key to the standing wave problems that we're studying here. Now, the question that we're dealing with, there's two really important bits of information. The material, the rope, I think it's a rope, does it say, yeah, rope, okay. The rope is 6 meters long. That can't change. But what does change is the wave that is in this rope. Now, in the first question, the wave has a wavelength of 12 meters. So with a wavelength of 12 meters, you should, from the discussion we just had and from your learning, you should have an idea of where you would find nodes on a 6-meter string. Because I don't really want to give this question away, so I'm trying to skirt around it but give you as many hints as I can. In part B, the wave that's being used, so different situation, is 6 meters. So you should have an idea of how far apart the nodes would be in this question. So each one of these is going to have their own diagram. So there's going to be 3 diagrams in this answer. And the third one, the wavelength is 3 meters. So once again, from our discussion and our knowledge of standing waves, you should know how far apart nodes are from each other. So the pattern will look different. So if you're really thinking about what the patterns should look like, I would definitely take a look again at the pictures on page 229 of the textbook. That'll also help you see the patterns that I'm looking for. And so it's all about where the nodes are. Okay, I hope this helps.